Hello friends, in our previous lecture we have started with exercise 1.2. We have completed two sums. Now we are going for the third sum. One family on page number 25, 1.2 third sum. One family is randomly selected from families having two children. Find the probability that one child is a girl, one child is a boy. At least one child is a girl, assuming that the two children among the two children of the family. Assume that the chance of selecting a child for a boy or girl is the same, that we know. So first a sample space will be required for a family having two children, that we have written in exercise 1.1 also, that a family can have both boys girl, girl boy and girl girl. And after that we have to make the events as per the information given. Okay, now friends, we are writing exercise 1.2 sum number 3. So sample space for selecting a family having two children is U is equals to BB, BG, GB, GG. This is the same like when two coins are there. That B into BG into BG we have done. See, if you want, I can explain like this: BG into G, BG. So B with B, so BB, B with G, so BG, G with B, so GB, and G with G, so GG. If you want, you can write this, otherwise directly you can write this thing. Okay, so here N is equals to 4. Yes. Now, event A is equal. Number 1 we are finding event A is equals to one child is a girl, one child is a boy. One child is a girl and one child is a boy. Elements for set A. One is a girl, one is a boy, so BG and GB. So here favorable outcomes are 2. Probability of event A, M by N, 2 by 4, 1 by 2. Next, number 2, event B. At least one child is a girl. At least one child is a girl among two children. Among two children. Now, at least one girl means one or more girls. Okay, what do you mean by at least one or more girls? So elements of set B: boy girl, girl boy and girl girl, all are possible because one is okay, more than one is also okay. So M is equals to 3. Probability of event B, M by N, 3 by 4 is the answer. Okay, so this sum is over. Going for fourth sum. One number is selected at random from first 100 natural numbers. Find the probability that number is divisible by 7. Okay. Question number 4. Sample space of a number selected from 1 to 100. U is equals to 1, 2, 3, 100. See, when we want to select only one number, so all will be written only one time. If you want to select two number, then 1, 2, 1, 3, 1, 4 same way. But but here we have to select only one number, so 1, 2, 3 and then. Okay, so n will be equal to 100. Now directly event A is equals to number is divisible by 7. Now I will explain one thing. Elements of set A, if it is possible to write, then you can write from 1 to 100 all the multiples of 7. And if suppose it is not possible to write, see here elements are so much, and if it is not possible to write, then directly we can calculate m is equals to 100 divided by 7. So what we will get in calculator, let's see. 100 divided by 7, 14.2857, which will be equal to 14 numbers. In that way we can do, because in exam it is not compulsory, no, they are asking from 1 to 100. If they are asking from 1 to 200, how can you get? So better way, when they are asking number is divisible by 7 from the numbers, or number is divisible by 3, or number is divisible, you find out the answer by dividing. Now leave all the decimals you ignore. Suppose if it is 14.92, then write only 14.92 you ignore. It is not that it is less than 0.5, so I am writing 14. You ignore the points, you ignore the digits after the decimal values. So 14.2857, so 14 numbers. Okay. So P of A will be equals to m by n, 14 by 100. Or if we can cut by 2, then 7 by 50. So this sum is also over. Now number 5. Question number 5. The sample space for a random experiment of selecting numbers u is equals to 1 to 120. So n will be equals to 120. Okay, and all the outcomes in a sample space are equiprobable. Find the probability that number is a multiple of 3. Now when it is asked about multiple or divisible, you just do the division only. Okay, 120 by 3, so elements will be 40. Not a multiple of 3. So friends, it is totally complementary event. Why complementary event? Why this is a complementary event? The reason is that event A shows the multiples of 3. And event A complement will show not a multiple of 3, means all the numbers excluding the multiple of 3 they will show. So you have to make the events in such a way. Then again multiple of 4, again event B, then not a multiple of 4, event B complement, because multiple of 4 is shown in event B. So opposite to it, not a multiple of 4 will be shown in B dash. So differently you don't have to find other elements. And multiple of 3 and 4 both. So which are the common elements which are coming in 3 and 4 both? 3 into 4, 12. How? I will explain it. Okay, let's write first. Number 5. Sample space for a number selected from 1, 2, 3, dot, 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 120. You write only this much. Sample space for a number select u is equals to 1, 2, 3, dot, 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 120. So n will be equal to 120. Now number 1, event A, multiple of 3. So friends, when they are asking multiple or a divisible, always do the division, because elements are not possible to write. Okay, so when the elements are not possible to write directly, 120 are the total numbers divided by 3, so 40. So P of A is equals to m by n, 40 by 120, which will be equals to 1 by 3. We will cut it by 40, 40, so 43 is 120. Now next event is to understand event A complement. Why complement? Not a multiple of 3. So it is not possible to find it directly, not multiple of 3. So we are finding totally opposite to each other, then always use complementary event. Okay, because it is in the definition of complementary event itself when the events are opposite to each other. And exact meaning of complementary is that elements which are in U but not in A. So in A it is having multiples of 3. So in A complement it will not have a multiples of 3. So P of A dash is equals to 1 minus P of A. As the total of probability is 1, from that one we are subtracting these elements, so we will get the remaining elements. So 1 minus 1 by 3. So like accountancy we are doing here, nothing is there, so 1, so 3 ones are 3, 3 ones are 3, 1 ones are 1. See, 3 ones are 3, 3 ones are 3, 1 ones are 1. So element will be 2 by 3. Okay. Then third, event B, multiple of 4. So favorable outcomes will be 120 by 4 is equals to 30. So P of B will be equal to M by N, 30 by 120, which will be equal to 1 by 4. Okay, again opposite to it. Event B complement, not a multiple of 4. Event A shows the multiple of 4, so complementary of it will be the elements which are in U but not in B. In B it is having multiples of 4, so in B complement it will not have any multiple of 4. So again P of B dash is equals to 1 minus P of B. 1 minus 1 by 4. 4 ones are 4, 4 ones are 4, 1 ones are 1, so 3 by 4. P of B dash. Fifth one. Event A intersection B. Why I am writing intersection B? Because they are telling the multiples of both 3 and 4. Multiples of 3 is A, multiples of 4 is B. Now they are asking multiples of 3 and 4 both, so it will be their common elements. Okay, so we are doing it that way. So multiple of 3 and 4, which shows 3 into 4 is equals to 12's multiples. It is showing multiples of 12. So M is equal to 120 by 12, 10. P of A intersection B, M by N, 10 by 120, 1 by 12. So why we are solving it this way? See, here it is showing multiple of 3. They are asking the question multiple of 3. Then for not multiple of 3, why we are making it a complementary event? Because it is easy to find. Because in event A all the multiples of 3 are there. So in event A dash none of the numbers will be there without the multiples. Okay, so directly we are finding the opposite event, so we are using complementary event. In the same way for B and B dash also. Now here why we are using intersection event? Because see, event A is showing multiples of 3, event B is showing multiples of 4, and here we need both multiples, means multiples of 12 we need, because 3 into 4 all the multiples of 12 we need, so directly multiple of 12, so 120 by 12, 10 numbers, 10 by 120, answer is 1 by 4. So at a time you have to think that the events which you are finding are totally opposite, then use complementary event, and events are common, then use intersection event. Okay friends, now we are taking the next topic, that is sum number 6. Now friends, one thing I may like to tell that from sum number 6, 7, 8, 9, 10, 11, then 12, till 12, the sums are different. Why different? Because they all are sums of permutations, means which is having permutations and combinations. See, in 11th standard we have learned these permutations and combinations. So I will first give their formulas and then I will ask you to solve the sums. Okay. So before writing any sum, write one thing. The same thing which we have learned in standard 11th will be used here. Important concepts about permutations and combinations. Important concepts about permutations and combinations. In that, number 1, combinations C used for selections. In standard 11th also I have given these notes also, that combinations C are used for selections. When elements are not possible to show, comma, directly we select the elements using combinations. How? See, in this previous sum, numbers were from 1 to 120. Now it is not possible to write all the numbers, and favorable outcomes of event A are multiples of 3. So again, all the multiples are not possible to write. So what we have done, directly we have divided. But in all the sum, division is not possible. So at that time you have to use the combinations directly. Suppose there are 5 boys and 3 girls, 5 boys and 3 girls. You have to select 2 boys and 2 girls. So 3C2 and 5C. 3 boys and 5 girls are there. And I will give you an example. There are 3 boys, there are 5 girls. You have to select 2 boys and 2 girls. So how you will select? Out of 3 boys you will select 2. So 3C2 into 5C2. Out of 5 girls you are selecting 2. So in this way. Now you need to know how this is found. Okay. So for that I am giving the formula. And I will give shortcut also to solve. Okay. Formula: NCR is equals to n factorial divided by n minus r factorial into r factorial. So if you don't know anything, you can use this formula, and I will show the shortcut also how to solve this thing. Okay, while we are solving the sums. Then next, number 2 is permutations P. Now permutations are used for arrangements. Then directly formula: NPR is equals to n factorial divided by n minus r factorial. So see, it is having n minus r factorial and r factorial, and this is only having n factorial divided by n minus r factorial. So these all things you have to know about the big sums. So whenever now we are solving the big sums, you need to know these things, and you have to write that in exercise 1.2, from sum number 6 to 12 they are all related to combinations, and 13 to 16 they are all related to combinations. Okay, in sum number 1 to 5 selections were there, but elements were there, so it was directly possible to solve the sum. But now when elements are not directly possible, so we are using these combinations and permutations, and that sums we will start from tomorrow. So that's all for today. Thank you so much.